So I want to talk to you about this concept of key features of graphs. Some folks refer to it as characteristics of graphs. You've already started out last couple of days figuring out the domain and range of a graph. We're going to expand on that a little bit. And there's one thing I want to cover here with this picture, this concept of maximum and minimum. You know what a maximum is? A maximum is the highest value that something reaches. A minimum is the lowest value. Um, Instead of using the word global, I'm going to use the word absolute. And you'll see when you have the key features list that we don't use absolute and local most of the time. I just ask you for a maximum and a minimum. But anyway, absolute maximum, absolute minimum are the highest values that a graph reaches, or the lowest value that a graph reaches. And then a local maximum or minimum is something like right in this area. We have a local max there where the graph reaches a peak but changes direction, goes back down there. So just want to make sure you understand that. There are things called local maximum and local minimums, and there are absolute maximums and absolute minimums. We'll talk more about that in high school. But so here we have a graph, and we have to list all of these key features. So let's start out with the domain and range. That you should be familiar with. So the domain is the leftmost x value that the graph reaches. So we can see here's kind of the left bound of that graph, -5. Now that is an open circle. So instead of brackets, we'll have parentheses on the left end. How far to the right does that graph go? Right here to +5. Doesn't go any further than that. So from -5 to +5, we do need a bracket on the right end, though. How about the range? What is the lowest y value that this graph gets to? That would be -4, and we actually touch it, so we'll use brackets. What's the highest y value that this graph achieves? That is +4. We actually touch it, so we'll use the bracket. All right. Next, we're going to talk about intercepts, x-intercepts and y-intercepts. An x-intercept is where a graph crosses the x-axis. This one's a little bit out of the ordinary here. Because it's an open circle, it doesn't actually touch the x-axis there, so that's not included as an x-intercept. But we do have an x-intercept here at 0, and we have another x-intercept at 5. So 0 and 5. Sometimes we actually write the order of pairs for those points. So you could write 0, 0, and 5, 0 for those x-intercepts. But that's x-intercepts. All right. Similarly, a y-intercept is where a graph crosses the y-axis. We only have one. Happens to be in the same spot as one of our x-intercepts at 0, or you could write out the order pair 0, 0. All right, so this whole concept of maximum and minimum, or the plural, maxima and minima. Do we have any local maxes, local mins on this graph? Well, there isn't a place like we saw on the previous page where the graph kind of reaches the top and turns down and gets higher later. However, you should see in high school that we include our absolute maxes as local maxes and mins. So this point right here is a local max, and it's also the absolute max of this graph. The graph never goes higher than that. So for a local max, we're going to put 4, and for an absolute max, we're going to put 4. In terms of minimum, let's see, that graph reaches a low point right here. We're going to include that as a local minimum and an absolute minimum. So that is, look over to the x-axis, that's -4. All right. Now, these next 4 key features, you see the word interval. Interval, interval, intervals, intervals. Whenever you see the word intervals, you should be writing your answers from the x-axis. We're looking at values from the x-axis. So interval of increase. Where is this graph increasing? Well, this graph is increasing right here to here. That graph is increasing. So we have to describe that interval on the x-axis. So I look where it starts increasing is right here. And I'm going to go up to the x-axis and look at that value, and that's about negative 2.5. And then it is increasing, increasing, increasing until we get to this point right here. I look down to the x-axis, and that is about 2.5. So that graph is increasing between negative 2.5 and positive 2.5. All right. Notice we use parentheses there. We don't need to put brackets there because the graph is not actually increasing at those 2 points, negative 2.5 and 2.5. That's where it changes. All right, now interval of decrease. So that graph is decreasing in two places. Here is the beginning of an interval of decrease, and we are decreasing, decreasing, decreasing until we get to this point. So let's express that interval. So we started decreasing at an x value of negative 5. And we stopped that interval of increase at negative 2.5. Notice that's where the previous interval of increase started. All right, we have one more interval of decrease, and that is right here to this point. So where did we start the decrease? Well, that was at 2.5, where we left off the last interval of increase. And we're going to run out of room here on the side. We're going to have it up here. So that second interval of decrease starts at 2.5 and ends at 5 on the x-axis. All right, and then we have this concept of positive and negative intervals. And when we're talking about positive and negative intervals, we want to know where our graph has positive y values or where our graph has negative y values. So the x-axis is kind of our dividing line. We want to look, where is our graph above the x-axis? Well, the graph is above the x-axis from here all the way to here. It is above the x-axis. And I need to describe that interval in terms of x values. So between 0 and 5, that graph is positive. Between an x value of 0 and 5, that graph is positive. All right, well, we also have a negative interval, and that is over here. Everywhere that I'm tracing here in orange, that graph is below the x-axis. So that is a negative interval. What is that interval? So between negative 5 and 0, that graph is negative. Turning points. Turning points are where a graph changes directions. So our graph is decreasing, 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 until we get to that point, and then the graph turns uphill. So that is one of our turning points, and we need to just write that order pair. That's negative 2.5, comma, negative 4. And we have one other turning point. We're going uphill, uphill. When we reach this point, the graph starts to head downhill. We just need to write that order pair for that turning point. That's positive 2.5, comma, 4. All right, end behavior. The end behavior of a graph is what is happening on each end of the graph. Now, typically, end behavior looks like this. As x approaches negative infinity, f of x or y approaches something, and as x approaches infinity, f of x or y approaches some value. Now, this graph doesn't have arrows on the end, so it's not going on forever. So here, our x values, as far left as we go, is -5. So we're going to say as x approaches -5, so as we travel this way on the x-axis, which is going along the graph this way, what y value do we approach? 0. And similarly, heading in the other direction, as x approaches +5, so as we travel this way on the graph, where are our y values approaching? Where are y values approaching? 0. All right, so there's one example of key features. Let's check out one more. And I'm going to add something on this graph. I'm going to add arrows on the end so we have kind of a little bit of a different example. So let's say we've got arrows on the end here. All right, so domain, what is the domain? How far does that graph go out to the left since we added those arrows? That graph goes out to -infinity on the x-axis. How about to the right? This way it would go out forever to +infinity. All right, range. Remember, range goes from bottom to top. How far down does this graph go? Down to -infinity. But this graph does actually have a top, which is right here. What is that? That is 8. And we do touch 8, so we use brackets. All right, any x-intercepts? Does that graph cross the x-axis anywhere? It does at 0 and 12. Does that graph cross the y-axis anywhere? Yes, it does. Our y-intercept is 0. Local max, local minimum, absolute max, absolute minimum. So this graph does have a top, so it's got a max. The max is 8. That's a local max and an absolute max. And again, you'll see on your assignment, we don't distinguish local and absolutes. We just ask for a max and a minimum. Does this graph have a minimum? No, it does not. It goes down to forever, and you never reach forever. So this graph has no minimum. All right, interval of increase. Now we're always looking at a graph from left to right. So we're looking here. All right, that's where the graph is increasing. And now where does that increase begin? It increases way out there to the left at -infinity. And where does it stop increasing? It stops its increase right here. We have to go down to the x-axis, and that is 3. So between -infinity and 3, that graph is increasing. Do we have an interval of decrease? Yes, we do. This graph is decreasing here. Where does that decrease begin? That begins down at 9 on the x-axis. So our interval of increase begins at 9. Interval of decrease, sorry, begins at 9. And it keeps on decreasing forever as we move out to the right. So that graph is decreasing between 9 and infinity. Now something's going on that graph between 3 and 9. We don't have a spot for that, but between 3 and 9 is what we call a constant interval. The graph y value is not changing. It stays at 8. All right, so positive intervals. Where's that graph above the x-axis? That graph is above the x-axis everywhere along this line that I'm tracing. And that is between x values of 0 and 12. So the positive interval for this graph is 0 to 12. All right. How about the negative intervals? Well, that graph is below the x-axis here and here, and that goes out to forever land in each direction. So the negative intervals on this graph are from -infinity to 0 and from 12 to +infinity. As we move out to the right this way, it will always be below the x-axis there. Do we have any turning points? We do have 2 spots where something changes on the graph. We go from increasing to constant here and from constant to decreasing here. So these 2 points here are turning points. We just need to list those ordered pairs. All right, so they are 3, 8 and 10, 8. In behavior, so this time we do have what I was talking about in the last example. As x approaches negative infinity. That means as we hop on our graph and we move out toward the left side of the graph, what is happening? Where are our y values headed as we move left on our graph? Well, they are going down towards negative infinity. Okay, what's happening as x values approach infinity? That means as we move this way on the x-axis, so as we move this way on our graph, where are these y values headed? They are headed down towards negative infinity. So there's a couple of examples of some key features of graphs.